Hi guys, so kakauwi ko lang, galing school. Ayos muna ako, then proceed na ako sa report. I'm back guys. I'm Paul Jerome Medina and I'm gonna report color sensor. The first thing in my report is the color theory. What is a color theory? It is a general application of color principles to design. It involves different types of additive and subtractive color systems that define a palette of colors to be used online, digitally, or in print. Color theory addresses the full range and spectrum of possible colors by grouping them together in ways that help designers to reach final results or better understand how different colors are related. There are two types of color in the color theory. The first one is the primary colors and the second one is the secondary color. Primary colors are sets of colors that can be combined to make a useful range of colors. For human applications, three primary colors are usually used. Since human color vision is trichromatic, primary colors are divided into primary color additive and subtractive. At the lower left of the slide, you can see the colors for the secondary color, mainly the cyan, magenta, and yellow. While at the right side of the PowerPoint, you can see the colors for primary colors, mainly red, blue, and green. Secondary colors is a color made by mixing two primary colors. Primary colors are divided into two parts, mainly the additive and subtractive. Additive primary. An additive color model involves light emitted directly from a source or illuminant of some sort. Combining one of these additive primary colors with another in equal amounts produce the additive secondary colors. Combining all three primary lights or colors in equal intensities produces white. Next, we go to the RGB color modeling. An additive color model in which red, green, and blue light is added together in various ways to reproduce a broad array of colors, used in sensing and representation and display of images in electronic systems, such as televisions and computers. As you can see in the slide, there is the representation of RGB color modeling. Next is the system introduction or block diagram. Light rays from a color light source fall on the optical components of the color sensor. The optical components filter and focus the rays on the optical sensors. The output of the sensors is processed by the electronic circuitry and the corresponding color output is obtained. Photodiode is used in the optical component. What is a photodiode? Photodiode is a semiconductor diode that, when exposed to light, generates a potential difference or changes its electrical resistance. Figure 1 is a schematic representation of the present invention where the output of a secondary receiver is mathematically manipulated and used to divide the output of the primary receiver for the color sensing circuit. According to the present design, the light emitted from the light sources is carried to the object of the color to be measured using a fiber optic bundle. According to one embodiment of the present design, a portion of the fiber optic bundle is split off and directed back towards a secondary receiver, which measures the light output from the split off fiber optic cable and then uses that signal to either regulate the output of the light transmitters and or make correction for drip of the output of the light sources in the calculation of the level of reflected light from the object whose color is to be measured, and the use of an ultra-zero signal to prevent electronic saturation when the light sources are off. Color sensors are generally used for two specific applications: true color recognition and color mark detection. Sensors used for true color recognition are required to see different colors or to distinguish between shades of a specific color. They can be used in either a sorting or a matching mode. In sorting mode, output is activated when the object to be identified is close to the set color. In matching mode, output is activated when the object to be detected is identical within tolerance to the color stored in memory. Color mark detection sensors do not detect the color of the mark, rather, they see differences or changes in the mark in contrast with other marks or backgrounds. They are sometimes referred to as contrast sensors. That ends my report. Thank you for watching and listening.